All right, we're going to talk about the work kinetic energy theorem today, and what we're going to do is we're going to start off by reviewing what we know about work. Well, we recently learned that work is equal to a force multiplied by the distance multiplied by the cosine of the angle between the force and the distance. For the purposes of this derivation, we are going to say that the entire force is going the same exact direction as the object is traveled. So if the force is being applied to the right, the object is traveling directly to the right, which means the angle between them is 0. The cosine of 0 is 1, so we're essentially multiplying force times distance times 1. Anything times 1 is itself, so I can kind of get rid of that for the time being. You may notice that we've got force up here. Well, we have an equation for force. Okay? Force is equal to mass times acceleration. So I'm going to substitute that in for the force. So my new equation is going to say work equals mass times acceleration times the distance traveled. Okay? These two variables, you may recall, were in our kinematic equations. So the next thing we're going to do is look at this kinematic equation. Now, this variable d was not in these equations. That's because we were traveling in the x direction, things like that. So we're just going to go ahead. These mean the same thing. The distance traveled, we just used x before. Now we're using d. So we're just going to change this x into a d. So we're going to have the final velocity squared is equal to the initial velocity squared plus 2ad. I want to solve for ad. That way I can substitute whatever I get in over here. So we're going to start off by subtracting the initial velocity squared from both sides. So I'll have the final velocity squared minus the initial velocity squared is equal to 2 times the acceleration multiplied by the distance traveled. Well, we need to get rid of the 2. You can divide by 2, but that's the same as multiplying by 1/2. So I'm going to choose to multiply by 1/2. The entire side, though. So 1/2 will cancel over here. I'm left with AD on the right-hand side. On the left-hand side, I have got 1/2 times the quantity, the final velocity squared, minus the initial velocity squared. So I'm going to take this, substitute it in for this. Okay? So now I have got the work is equal to mass multiplied by 1/2 times the quantity, the final velocity squared, minus the initial velocity squared. And the next thing I'm going to do is distribute the 1/2 and the mass to both. So I'll be left with work is equal to 1/2 mass times the final velocity squared minus 1/2 mass times the initial velocity squared. You may recall kinetic energy is 1/2 mv squared. So this is simply my final kinetic energy. And this term is simply my initial kinetic energy. Anytime we take a final minus initial, we are simply finding the change in that quantity. So the net amount of work done is equal to the change in kinetic energy, and that is what the work kinetic energy theorem states. So the work kinetic energy theorem says the net amount of work is equal to the change in kinetic energy. This relationship is true even if there is friction. This is a little different than before. When we were dealing with conservation of energy, mechanical energy was only conserved if there was no friction. However, the work kinetic energy theorem is true no matter what, whether there's friction or not.